Good morning, everyone. I welcome you all to the first session on cryptarithmatic. Why this topic was chosen was because many people might be familiar with conventional topics like percentages, ratio and proportion. It is the same thing that is being taught everywhere. In these special sessions, we want to take some exotic topics which have seen a much more increased weightage in the recent CSAT. One reason for cryptarithmatic becoming a favorite of UPSC is, we all know that UPSC asks for, or rather in the syllabus, it is given that arithmetic ability till class 10. Okay. And we all know that since it has become from 21-22, when CSAT has become difficult, okay, UPSC has focused on applicability more. Okay, in topics like ratio and proportion, percentages, or simple and compound interest, as you want to increase the complexity, okay, you need to introduce new concepts. You need to introduce new concept or think in a different way. UPSC fears that this may be beyond reach of an arithmetic or ability of an that is expected of a class 10. But you will have no such problem with cryptarithmetic. Why? One, because it is what we have been doing from our childhood and all. Okay, we all know addition. We all know multiplication. All your cryptarithmetic is based on these two concepts only. Okay. So, what is cryptarithmetic? Okay. It is a combination of two words, cryptic, and second one is arithmetic. Arithmetic is arithmetic operations, your addition, subtraction, multiplication and division, so on and so forth. Okay. So, cryptic addition, what happens in a cryptic addition? Cryptic is something that is hidden. So, in cryptarithmetic problems, what you will see is numbers, okay, numbers being replaced by letters, okay, numbers being replaced by letters. So, all such type of problems are called cryptarithmetic problems, okay. And what are the fundamental concepts that they check upon? Whether we are good with addition and multiplication or not, okay. And this is the reason why any difficult topic in cryptarithmetic does not go beyond these two skills, your basic addition or subtraction, multiplication or division. So, it becomes a prime spot for UPSC if they want to set the paper hard. Okay, you will observe that on the top of my head, I can remember from 21 or 22, one example, ABC into D gives 37 DD, and he has asked something like what is A plus B plus C. Next, even in 25, the recent paper, we had at least 3 questions on cryptarithmetic, where numbers are substituted by letters and they are asking some, okay, some important thing from that. Okay. So, this session aims to give you an one-shot mastery at cryptarithmetic. So, what are we going to do? First, we will start with, okay, the basic concepts that are present. Okay. And this cryptarithmetic is purely, okay, it is not that there are some formulas involved. It is purely an applicative concept or applicative topic, where you, even if you know the concepts, you always need to apply. There are no shortcuts to be taken. There are patterns to be observed, but there are no preset ways to do a problem. Okay, it can be done in any ways, in many of ways. Okay, so first we are going to see basics. Next, we are going to look at some observations, or I am going to give you some patterns where in any cryptarithmetic problem, these patterns will definitely be inherent. Once you observe this pattern, solving the problem becomes much more easier. And then At the last, we'll solve some problems. Okay. And the level of this session is going to be as with every class. Okay, we are going to, okay, we are not just going to, okay, stop at the level that UPSC is asking. Okay, we will see the concepts. Okay, we'll approach all of those concepts. You may get a feeling that some of these questions that have been prepared might not be asked in CSAT and all. I'm okay with that, because I want you to prepare to a level such that when you face a CSAT problem, when you face an UPSC CSAT problem, it becomes easier. So the level that we will be aiming for is much more than that of CSAT, and the questions are also in such a way that all the patterns that we will discuss here, okay, you will be able to observe these patterns, or you will be able to rather apply these patterns, so that any cryptarithmetic problem becomes just a walk in the park for you. Okay, so let's start with the basics first. Okay, I add two numbers at the risk of sounding repetitive. Okay, although we all know how to do addition and subtraction, multiplication and all, I would like to start with what happens when you add two things. Okay, a plus b. In many of the cases, the digit will be, okay, the resultant will be one digit. In some cases, the resultant will be two digit. This is called unit digit, and this is called tens. Or, okay, especially in case of addition, we might sometimes call this carry. Okay, next, what is the further progression? Let us add two digit numbers. Okay, when you do b plus d, okay, it might result in, the result might be of one digit, the result might be of two digit. Okay, the result might be of one digit, the result might be of two digit. So b plus d, okay, if it results in x and y, how are we going to do? We are going to take y as it is, the unit digit as it is, and we are going to take x to the next place. Okay, so this is called carry. Okay, now the tens place becomes a plus c plus x. Okay, so this is a plus c plus x. Okay, so what do we observe from this? Okay, so we'll start the patterns from here itself. One, you are always your unit digit, okay, or the rightmost digit. Okay, rightmost digit is purely a combination of unit digits only. Okay, that means your unit digit of the result, okay, always depends upon the unit digits of the sum. Okay, so it depends upon unit digits only. Okay, any digit except the right digit, any digit except the rightmost digit depends upon, okay, let me just write this here. Okay, unit digit, property 1, unit digit only depends upon, this is result. Okay, results unit digit depends upon unit digits of sum. Okay, next, any digit except unit digit, okay, the result depends upon, okay, two things. One, okay, if a carry is involved, it will involve a carry or digits of same place value. Okay, digits of same place value. Okay, although it might be a more of theory. Let us see it practically. 37 plus 68. Okay. According to property 1, always your rightmost digit or unit digit depends only upon the rightmost digit itself or the unit digit itself. So 7 plus 8 is 15. Okay. You will never have a carry in this unit digit. So 15 is 1 and 5. So 5 comes here, 1 acts as a carry now. Okay. Now this becomes, okay, 3 plus 6 plus 1, okay, which is 10. So the resultant is 105. Okay. So what do we get from that? In any of the addition properties, okay, always, since your unit digit only depends upon the unit digit, okay, which is obviously clear, will be clear to you, you will always start or try to start it from unit digit itself. Why? The permutations of the result are very less. It only depends upon what are you adding in the digit. But whenever you take any digit, okay, whenever you take any digit except the unit digit, it depends upon both the addition and the carry from the previous digit addition, okay, and the carry from the previous digit addition. So because it is getting complicated here, okay, whenever you want to solve a problem, you will always start with, okay, 1. You will always start with unit digit or, okay, I call this edge points or edge digits. What are edge digits? Suppose A, B, C, D has resulted in X, Y, Z, okay. Z and X, since they are at the edges, okay, most of the problems will be solved if you focus on the Z and the X, okay. Next, so this is pattern 1. So we have seen how an arithmetic operation happens, okay. So we have seen one pattern. What is that pattern? Always start dealing with a problem with the unit digit. Why? Because unit digit does not contain a carry, okay. The number of permutations will be less and you will be able to solve the problem much more faster. Now let us see multiplication. AB into CD. What are we going to do? First we are going to multiply AB into D. Suppose this gives me M, N and O, okay. So it gives me M, N and O, okay. I will leave one digit. Next I will multiply AB with C. Suppose this gives me X, Y and Z, okay. Suppose this gives me X, Y and Z, okay. I will add these two, okay. So this will become, this is not 0, this is O, or let me take this as P, NP, okay. This is P. You add N plus Z here, and if it gets a carry, the unit digit is here, the carry gets carried to the next one, okay. M plus Y plus carry 2. Next, if this also produces a carry, this is X plus carry 3, okay. So in a practical scenario, 27 into 35, okay. First we multiply 27 into 5. 27 into 5 is 135, okay. Next 27 into 3, okay, 81. So 5, 4, 9, okay. So it is 945, okay. Now, so this is the basic multiplication. Now, what can I teach you? What patterns can I teach you here? What patterns can I teach you here so that multiplication becomes much more easier? Multiplication or your way of finding the patterns becomes much more easier, okay. You see what is happening? Any number of digits either in the multiplicand, okay, either in the multiplicand. Okay, what are we initially dealing with? We are dealing with it as a product of a single digit multiplication only. 27 into 35. Okay, the result is derived by first multiplying 27 into 5. Okay, and then multiplying 27 into 3 and adding both. Okay, so all multiplication is nothing but multiplication. Okay, of multiplication of n numbers is nothing but multiplication with a single digit and their addition. Multiplication with single digit and their addition. Okay, I hope you got this. So now this becomes much more important since we are always multiplying with a digit. Since we are always multiplying the digit, what can we do? We can find some patterns easily here. Okay, what are those patterns? I told you. In addition, we have made an observation. What is that observation? Always focus on the unit digit. In the same way, okay, in multiplication too, we will focus on the unit digit itself. Okay, so what are some apparent patterns? 1. Okay, A multiplied by B, A multiplied by B, or let us start with something much more simpler. A into A is A. Okay, 2 single digits multiplied by itself, 2 single digits multiplied by itself, okay, will result in the same, Now whenever you see a pattern of this kind, okay, there are only few possibilities. I want you to remember this. What are the possibilities? 1 into 1. Okay, A into A kind, it is 1 into 1. What does it result in? 1. Next, 5 into 5. It also results in 25. Okay, since we are only concerned with the unit digit, if A into A, okay, if you see a pattern of A into A, then it is either 1 into 1, which is 1, 5 into 5, which is 25. Next, can you name any more such patterns like this? Okay. 6 into 6 is 36. Okay, since we are only concerned with the unit digit, okay, it is 6 again. And next, 0 into 0, if you want, okay, it is also a 0. Okay, so from now on in cryptarithmetic, whenever you find a pattern of this kind, okay, 2 digits being multiplied and the resultant is composed of the same digit, then definitely the digit has to be either one of 0, 1, 5 or 6. Okay, 0, 1, 5 or 6. Okay, so this is the pattern for A into A. Whenever you see this pattern, A into A is equals to A, okay, the A can be either 0 or 1 or 5 or 6. Okay, I hope unit digit being one of the digit. Okay, so how many chances we have of this? Okay, so the first case is, okay, suppose I take A as any odd number. Okay, I take A as any odd number. If my B is 5, what will it always result in? It will always result in 5. You see the pattern here? Any odd number, take 3, 5, 7 or 9. 3 5s are 15. Okay, ends with a 5. 5 5s are 25, ends with a 5. 7 5s are 35, ends with a 5. 9 5s are 45, ends with a 5. Okay. So, whenever you see the pattern of this kind where two digits are multiplied and the resultant unit digit is one of the digit itself, then okay, what are the possibilities? B, okay, the digit that is being repeated is definitely 5, okay, and A has possibilities of odd number, okay, A has the possibilities of odd number, okay, A has the possibilities of odd number. I hope this is clear, okay. This is case 1. Now, the same thing can also happen. A into B is equals to B, okay. A into B equals to B when if A is 6 and BB, okay, if A is 6 and BB any unit digit, suppose 6 2s are, sorry, any even digit, okay, take 0, 2, 4 or 8, okay, because 6 into 6 we have already covered that in A into A, okay. So, you see 6 zeros are, the resultant is 0, 6 2s are, the resultant is 2. So, whatever you are multiplying with 6, that is resulting in the same digit, okay. 6 4s are 24, 6 8s are 48, you see, multiply by 8, the resultant is 8, multiply by 4, the resultant is 4, the resultant unit digit is 4, multiply by 2, the resultant unit digit is 2, multiply by 0, the resultant unit digit is 0. So, what can we guess from this pattern, okay. This is case 1 and case 2. Whenever you see A into B equals to B, whenever you see A into B equals to B, then A has, okay, A has two possibilities, or there are two cases for A, okay. If A is 6, okay, the cases for A is case 1, okay, A is an odd number or A is 6, you see, A is either a odd number or A is a 6, okay, A is either a odd number or it is 6. Now, okay, in case if A is the odd number, B will obviously be 5. If A belongs to an odd number, okay, and B, the value of B is definitely going to be 5, okay. Next, in the case where A belongs or A is 6, okay, A is 6, then your B has to be an even digit and it will result in the same even digit itself, okay. So, let me just summarize the patterns that we have seen now, okay. First we have seen A into A resulting in A, okay. This is only possible, okay, in 4 cases, either when A is 0 or 1 or 5 or 6, okay. Next, in the pattern of A into B is equals to B, A has two possibilities. A can be an odd number or A can be 6, okay. A can be 6. In case if A is an odd number, your B is 5, okay. Your B is 5. Take any example, 3 into 5, 15, 7 into 5, 35, okay, 9 into 5, 45, excuse me, 9 into 5 is 45. In all the cases you will have 5 as the resulting and B is 5. In case of A being 6, okay, A being 6, then B is any even digit and the resultant unit digit will also be the same even digit, okay. the same even digit. Okay. So in the case of whenever you see pattern of this kind, A into B is equals to B, A is either an odd number or the number 6. Okay. Next. The third pattern that is, okay, if the unit digit is 1, okay, if the unit digit is 1, it only has two possibilities. Okay, if the unit digit is 1, it only has two possibilities. We all know it is 1 into 1. Okay, if A into B results in a 1, okay, then A and B are either 3 into 7 or 7 into 3. Okay, only these two numbers A and B, if the unit digit is 1, if the unit digit is 1, okay, then of unit digit of the resultant is 1, okay, then your digits has to be either 3 or a 7, either 3 or a 7. Okay, I hope these patterns are clear. Okay, once you get these, you will definitely solve any cryptarithmetic problem. Okay, the patterns are A into A is equals to A. Okay, A into A is equals to A. That means A can be either 0, 1, 5 or 6. Next, A into B is equals to B. Okay, A could be an odd number, A could be an odd number or 6. In the case of it is A being an odd number, B is 5. Okay, and it will result in B being 5. Next, in A being an 6, okay, you will always have an even number. B is always an even number. Okay, and the third pattern is whenever you see 1, whenever you see product of two digits result in the unit digit being 1, product of two digits resulting in unit digit being 1. Okay, the only case is, okay, both the digits have to be either 3 or a 7. Okay, either 3 or a 7. Okay. Either 3 or a 7. Okay. If you just remember these patterns, okay, the basic way of addition or multiplication, okay, we all grew up knowing that from our childhood onwards. Okay, just add the information regarding these patterns here. Okay, the information regarding these patterns here, okay, you will solve any cryptarithmetic problem. Okay, so I hope the concepts are clear. Okay, now let us apply them. Okay, so we'll start with some problems on cryptarithmetic. Okay, and do not be at sea. Okay, whenever you see cryptarithmetic problems, first do not be at sea. Implement the observations I have told you. 1, always attack the unit digit. Okay, or A, B, C, D, something X, Y, Z, P. Okay, always attack the edges, either the unit digit or, okay, the rightmost or the leftmost digit. Okay, always attack the digit at the edges. And next, what is the second pattern that you are going to look for? You look for repeatability or the pattern being made. Okay, what are the patterns that are made? A into A is equals to A, or A into B resulting in B, or the unit digit being 1, which means the digits involved are 7 or 3. Okay, always attack at the extreme, okay, edge digits and look out for repeatability or patterns. Look out for repeatability or patterns. Keep these two things in mind. There is no one that you can, okay, that no problem that can stop you from solving it. Okay, so okay, so once I write the problem, I want you to pause the video, or if you are online, okay, solve the problem for a few minutes. Okay, I know many of you might get the answer, might not get the answer. Okay, and this is all what I always repeat in the class. The answer is not important. Your approach to the answer, your thinking ability is what matters. Okay, and suffer through the problems. Okay, it is not that you will get the answer. Suffer through the problem. The mind that does not suffer, that will not grow. Okay, so pause the video, do the mistakes, okay, and then compare it to my solution. Okay, there you will know, okay, the best way to approach and solve the problem too. Okay, so the first problem goes like this. Okay, a four digit number A, B, C, D. Okay, a four digit number A, B, C, D. Okay, when multiplied by 4, a four digit number A, B, C, D. Okay, when multiplied by 4, okay, when multiplied by 4, okay, reverses itself. Okay, reverses itself. Okay, a four digit number A, B, C, D. Okay, when multiplied by 4, a four digit number A, B, C, D, when multiplied by 4, okay, the resultant is nothing but the reversed number, the reversed A, B, C, D itself. Okay, sum of A plus B plus C plus D, or anything could be asked, A, B by C, D. Okay, these all are derivatives. Once you get the values of A, B, C, D, any question that UPSC asks A, B, C, D, or they might ask you A into B plus C into D. Okay, every derivative result is dependent upon you knowing the value of A, B, C and D. Okay, A, B, C and D. So the problem is A, B, C, D when multiplied by 4. Okay, when multiplied by 4 results in D, C has reversed itself. Okay, reversed itself. D, C, B, A. D, C, B, A. Okay, I want you to find out what is A or B, values of A, B, C or D. Okay, values of A, B, C or D. Once you get the values of A, B, C or D, okay, any question they ask for, okay, is just a derivative of these. Okay, okay. I hope everyone online is trying this. We'll start the solution. Okay, if you are still solving the problem, you could pause the video. Okay, we'll start the solution in a few seconds. What? Okay, now let's start. Okay, A, B, C, D into 4 gives me D, C, B, A. Okay, so for me to avoid confusion, what I do is I'll name my digits, okay, at the edge of this 4, 7 and 8. Okay, now first I'll start with the edge cases. Edge cases is this: D into 4 results in A. A could be any number, right? I know A is an even digit. A is an even digit. Apart from this, can I make or am I able to find any patterns here? Okay, A could be any of 0, 2, 4, 6, 8, any of the even digit. Okay, so I am unable to find a pattern here. Okay, so I will go to the next edge, which is B. Now look at this. A, B, C, D, even after multiplying by 4, even after being multiplied by 4, has resulted in a 4-digit number only. A 4-digit number only. Now this gives me an idea. Okay, suppose ABCD is 2500 or any number greater than or equals to 2500. When you multiply it by 4, it becomes a 5-digit, right? When you multiply this by 4, it becomes a 5-digit. But our result is still a 4-digit number. Our result is still a 4-digit number. So what needs to happen here? Okay, that means, what does this mean? A, B, C, D must be less than 2500. Do you agree with this? Whenever any value greater than 2500 is multiplied by 4, it will result in an 5-digit result, okay, or a 5-digit number. But since our result is a 4-digit, that means it has to be less than 2500. Okay. Now what are the cases for A? Either it is in 2000s or it is in thousands. Okay, it can't be in 0999, right? Okay, so the case for A, is either A is 2 or 1. Okay, the case for A is either it is a 2 or 1. Why? Because ABCD when multiplied by 4 will result in a 4-digit number. That means ABCD has to be less than 2500. So what are the possibilities for 2500? Either the number is in 2000s or is in 1000s. Okay, if it is in zeros, it will be a 3-digit number, right? Okay, so A is either 2 or a 1. Okay, A is either 2 or a 1. Now you see. Okay, this is why I tell you finding out the patterns is important. Now look at this. Anything multiplied by an even digit, what will it result in? Always, okay, 2 into 3 is 6. Although you are multiplying an even number with an odd number, the result is always going to be an even number. Okay, resultant is always going to be an even number. So when you are multiplying with 4, okay, if this is 1, this has to be 1, right? If A's value is 1, this also has to be 1. But will it ever be 1? After multiplying by 4, will you ever get an odd digit? No, it always has to be an even digit. So, okay, 1 is out of question here. Why? Because after multiplication with 4, you will always get an even digit. So, the value of A is 2. Now, substitute this. Okay, so our equation becomes 2BCD into 4. Okay, BCD 2. Okay, BCD and 2. Okay, now I hope this part is clear. Now focus on this. Okay, what multiplied by 4 results in a 2? Okay, always in, okay, now let me give you another property, okay, a property of even multiplication, okay, which is any number or an even table, 2 table, okay, 4 table, 6 table, 8 table, whenever, okay, it is being multiplied, the resultant always will be even, either that is 0, 2, 4, 6 or 8. Okay, 0, 2, 4, 6 or 8. Okay, a table consists of normally a unit of 10. That means this unit of 0, 2, 4, 6, 8 has to repeat 2 times, okay, has to repeat 2 times. For example, I am listing 4 table here, so that you will be able to easily recognize the pattern. 4 ones are 4, 4 twos are 8, 4 threes are 12, 4 fours are 16, 4 fives are 20, 4 sixes are 24, 4 sevens are 28, 8s are 32, 9s are 36, 10s are 40, okay, 4 10s are 40. What do you see here? The unit digit is a repetition of 4, 8, 2, 6, 0, even digits only, and again see 4, 8, 2, 6, 0, okay. So whenever you multiply any even, okay, whenever you multiply any even table, or the property of any even table is the unit digit repeats twice, okay, repeats twice for a case of 10, okay, repeats twice for a case of 10, okay. So what are the possibilities for D? We know it is 2. So what are the possibilities? 4 threes are 12 and 4 eights are 32, okay. Both result in, okay, both result in the unit digit being 2, okay. So now D goes for 3 or 8. D is either 3 or 8. Now look at this. Same, it is, okay, all cryptarithmetic is like this, okay. Reduce to the possible observe the pattern, reduce to the possible combination, and put the value here. You see, I am multiplying 2000, okay. The value of D is either 3 or 8. The value of D is either 3 or 8. Now tell me, you are multiplying a number of 2000, of the value 2000, you are multiplying it by 4. Can it result in, okay, can the result be anything in the range of 3000? You are multiplying a number of value 2000 into 4, okay. Can it any time become or result in any number in the scale of 3000? No, okay. So it definitely has to be 8, okay. Since 3 is not possible, why 2 into 4 is, okay, a number of stature or number of value 2000 into 4 will result in something greater than 8000 or something of in the level of 8000 or greater than 8000, okay. It will never result in something of 3000, okay. So D value cannot be 3, so it is 8. Now, okay, we have already solved 2 of the 4 digits. So 2, D value is 4. First we have solved A is equals to 2 and now D is equals to 8. So the resultant becomes now, or the problem becomes 2BC8, okay, 2BC8 into 4 result in 2, 8, okay, C and D, okay. Now look at this, C multiplied by 4, C multiplied by 4, and I told you whenever except the rightmost digit, any unit digit depends upon not only on the product but also on the carry. You see 8 fours are 32, 8 fours are 32, that means there is a carry of 3 here, that means there is a carry of 3 here, okay. So D results in C into 4 plus 3 is D, sorry B, sorry, D, okay. C into 4 plus 3 results in B. I hope you understand the pattern now. Anything multiplied by an unit, okay, anything multiplied by an even digit will result in an even number, plus you are adding a 3 here, you are adding an odd number. So B has to be an odd number. B has to be an odd number. I hope you got this, okay. Now let's hunt for the values of B. and B is 8. Okay. Now let's hunt for the values of B. You see again, something in 2000s multiplied by 4, something in 2000s multiplied by 4 is resulting in something in 8000s, something in 8000s. Okay, is this clear? Something in 2000s multiplied by 4. Okay, so can I draw any observation from this? 2250 into 4 is nothing but 9000. Okay, 2250 into 4 is 9000. But what is our result? Our result is still in the range of 8000. Result is still in the range of 8000. So don't you think our 2BCD has to be less than 2250, right? 2250. Okay, 2250. Okay. So now let us see the possibilities for D. Okay, it could be something in 2200s or something in 2100 or something in 2000s, right? The value of ABCD, the value of ABCD has to be less than 2250. Why? Because the resultant is in the range of 8000. The resultant view is in range of 8000. So when you reduce, okay, when you deduce from this, that means the value of ABCD has to be less than 2250. So what are the possibilities? 2200s, 2100s. What are the values less than? Okay, 2250 and greater than 2000. Okay, 2200, 2100, 2000. Okay, now you see. So the value of B can be 2, 1 or 0. The value of B can be 2, 1 or 0. Now you see, C multiplied by 4, C multiplied by 4 plus 3, C multiplied by 4 will result in an even digit. You are adding an odd digit to it. You are adding an odd digit to it. So what will be the result? The resultant is B has to be odd. B has to be odd. You see, the only 2 is an even, 0 is even. So this is not possible. This is not possible. So the only possible thing is 2 and 1. So the value of B, the value of B is 1. Okay, the value of B is 1. So now so what did we find out? The value of, okay, we have found out value of A, the value of B, we don't know C, the value of is 8 into 4 gives you, okay, gives you 8. We still don't know the value of C, 1. And this is 2. Okay, and this is 2. Now you see, now we need to find out the value of C. Okay, now let's focus on this. Let's focus on this. We know 8 4s are 32. Okay, that means 2 comes here. So the carry is 3. The carry is 3. Okay, so 4 into C plus 3 is resulting in an 1. 4 into C plus 3 is resulting in a 1. What are the possibilities for it being a 1? Okay, C has to be, okay, or the product has to be, this product has to be, have a unit digit of 8, then only it will become 1, right? Okay, take any number. 28 plus 3 is 31. Okay, the unit digit has to be 8, then only you will get a unit digit of 1 or 30 or so 4 into C has to result in an unit digit of 8. 4 into C has to result in an unit digit of 8. So what are the possibilities? C could be 7, 7 fours are 28 or 2, 4 twos are 8. Okay. 4 into C plus 3 results in a 1. 4 into C plus 3 results in a 1. So that means the product of 4 into C has to have a unit digit of 8. Then only your unit digit becomes 1. Okay. Then only your unit digit becomes 1. So C has to be either a multiple of 7. 4 sevens are 28, or C has to be 2. 4 twos are 8. So 2 is already for A. So is 2 possible here? No. So the value of C is 7. Okay. So the value of C is 7. So finally, have we found out the answer or not? Okay. A, B, C, D is nothing but A value is 2, B value is 1, C value is 7, and D's value is 8 multiplied by 4. Okay. Multiplied by 4. Okay, we are just checking the answer. 8 fours are 32. Okay, 7 fours are 28 plus 3, 1. Okay, next 4 ones are 4 plus 3, 7. 4 eights are 4 twos are 8. You see, A, B, C, D has become D, C, B, A. Hasn't the number reversed? Okay. So this is how you solve. Okay. And from here, anything they ask, A plus B, value of A plus B plus C plus D is just simple addition here. Okay. I hope you understood the logic here. Okay. Have we done anything except the patterns? Okay, and the observations. What are the observations? Okay, I am repeating them again. Always focus on the edge digits. Focus on the edge digits. Okay, next. Sometimes we need to take range into consideration too. Okay, in the previous problem, how have we seen? Okay, some number in 2000s multiplied by 4 gives you 8000. Okay, so range can be taken into focus. Next, patterns. Okay, what are the patterns? For any even, okay, even multiple. Okay, if the resultant is 1, okay, or the unit digit is 1, it is 3 into 7, or the 3 patterns that we have seen. Okay, A into B is equals to B. Okay, or A into A is equals to A. Okay, so just focus on these parameters, okay, and these observations, you will solve any of the cryptarithmetic problem. Okay, now let us solve one more. Okay, this is a common question. I think most of you have seen this. Okay, common standard question. A number is multiplied, BOB. I hope many of you know Bob Marley. Bob Marley is an famous musician. Okay. I think he has some famous band. I am forgetting its name. Bob Marley, Mike Jagger. Okay. The question goes this: a number BOB multiplied by the number itself BOB, okay, results in M. a 3-digit number BOB multiplied by BOB results in this. Okay. I want people online, I want you to pause the video, okay, and start attempting the question. Okay. You will not learn until and unless you suffer through the problem. Okay. We'll see the solution in just a few seconds. I hope most of you have solved this. Okay, now let's look for the answer. Okay, so all our cryptarithmetic is a unit digit multiplication. Okay, a unit digit multiplication and then addition, right? A unit digit multiplication and then addition. So what will this be? Okay, BOB multiplied by B. BOB multiplied by B results in MEOY. Okay, so I am finding the pattern cell BOB multiplied by B. Okay, BOB multiplied by B gives you MEOY. Next, BOB multiplied by O. BOB multiplied by O gives in Milo. BOB multiplied by O gives you MILO. Okay, gives you MILO. Okay, now we need to find out what does B stand for, O stands for, okay, Y, E, O, okay, M, so on and so forth. Okay, now are you okay? Same patterns that we have seen. Okay, attack from the edge digits. Okay, focus on either this or this. Are you able to find anything? B into B multiplied results in a Y. So this Y could be any one of the 10 digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so but you see I see M here. This is all Marley is because of addition of all these, right? Okay, addition of all this. So you see, and we know that addition, okay, addition in all the digits except the rightmost digit depends upon the own addition, their own addition plus carry, their own addition plus carry. You see, M has become M. M has become M, so nothing is being added. You see, that means okay, there are no digits present here, but M plus E, M plus E. What is the maximum? Okay, what is the maximum that you can get for addition of two digits? Suppose what is the maximum digit? 9. 9 plus 8 is okay 1 plus 8. So okay, the maximum carry you can get when you add two digits. The maximum carry that you can get when you add two digits is definitely 1. Okay, so although no digits are present here, it simply is the carry from here. It is simply okay the carry from here. So what is the value of M? Okay, what is the value of M? Most probably it is going to be 1. Okay, most probably it is going to be 1. Okay, Now let us focus on this. Okay, BOB into B is equals to MEOY. Next, BOB into O is equals to MILO. Okay, let me just make sure I have got everything. BOB into BMIO is MILO. Okay, this is MI. Okay, now focus on this. Always edge digit. Okay, you see, B into B is Y. Next, B into O results in a O. Now I find a pattern here. Don't you think this is the pattern of our second kind, that the pattern that we have discussed? A into B results in a B. Okay, A into B results in a B. You see, B into O has resulted in an O. Okay, B into O has resulted in an unit digit being O, and the same case you see here, B into O has resulted in a unit digit O. Okay, all cryptarithmetic problems are pattern finding problems only. Okay, B into O has resulted in an O, and the same thing, okay, B into O has resulted in an O. That means what is happening here? That means B and B into B is not producing any carry. Okay, B into B is not producing any carry. Okay, B into B is not producing any carry. So what is B? B into B is nothing but B square. Okay, how many squares does not produce a carry? You see, what is 2 square? 4. 3 square? 9. 4 square? 16. The carry comes here again. Okay, so there are only 2 cases, okay, in which a square of 2 digits does not produce a carry. It is 2 and 4. So B has to be either 2 or 3. Okay, B has to be either 2 or 3. Okay, now look at the pattern here. A into B is B. Now what did I tell you for A? What did I tell you? The possibilities for A could be an odd digit or it could be 6, right? A could be an odd digit or 6. Look at pattern 2, which is A into B, okay, equals results in B. The possibilities for A are either an odd digit or it being a 6. If it is odd digit, B is 5. Okay, B is 5, so the resultant will be 5. And if it is 6, B is any even digit will result in the same even digit. Okay, same even digit. Now you see, so the possibilities for A are either odd number or 6, either odd number or 6, either odd number or 6, and okay, either an odd number or 6. And next, B into O, okay, is equals to O. Okay, B into O is an O, and the square of B, and square of B does not result in a carry. So the possibilities for B are, okay, the possibilities, okay, now I am considering these 2 patterns sine. Okay, B into B has to produce O. Sorry, B into B is Y. Okay, B into B is Y. Sorry, B into B is Y. B into O is O. Okay, these 2 are the patterns that I find here. Okay, this is repeatability. This is my attacking point. B into O is equals to O. So this is of the kind A into B equals to B. So what are the cases for B? The cases for B are either it is a 6 or it is an odd number. Okay, either it is a 6 or it is an odd number. Once I take this into into consideration, A into B results in a B. A into B results in a B. What are the possibilities for A? A is either an odd number or a 6. Now just substitute this here. This is all of the same pattern, right? B, okay, A is substituted by B into O results in an O. So B is our O here, okay. Now that means, okay, so this is of the same pattern, okay. So B has to be either 6 or an odd. And next, B into B is a Y, and I find that it has no carry. B into B does not have a carry. So what are the only two digits which does not have a carry, okay, whose square does not have a carry? It is either 2 or a 3. So B is either a 2 or a 3. Now you see, it can be a 6 or an odd, or B can be either 2 or a 3, okay. Can B be 2? No. Why? B has to be odd or a 6, okay. So it can't be 2. So B value has to be 3. So B is equals to 3, okay. So if B is odd, okay, then what is the, okay, what does it tell for the value of O? A into B, the property, remember this property, A into B is equals to B. If A is odd, B has to be 5, so the value of O is 5 here, okay, the value of O is 5. So haven't we finished the problem? You see, BOB is nothing but 3, 5, 3 into 3, 5, 3, okay. What will this result in? Okay, 3 3s are 9, 3 5s are 15, 3 3s are 9 plus 1. Next, 5 3s are 15, 25, 26. 5 3s are 15 plus okay, 17 plus again 1 0 5 9. 1059. So it is 9, 10, 16, okay. So these are MARLEY, okay. So have we solved it? And this is MEOY, and this is MILO, okay. So 1 2 3 4 5 6 7 8 9. First, how have we solved the problem? By first finding out what is the value of B, okay, B and O, okay, B and O. The value of, after that, okay, once we have found the multiplicants, okay, the resultant is just an arithmetic operation, okay. So from this 1 is equals to M, 2 is equals to A, 4, do we have a 4? No. Do we have a 6? Yes, L. 7 is I. And 9 is Y, okay. Bob, MA, what is R? R is 3, sorry. Okay, so once you get this, and okay, you see the problem might appear difficult, but what are we doing? Okay, even in the first case and even in the second problem, okay, we have not done anything outside, okay, the patterns and attacking the edge digits, okay. So I know UPSC might not involve these many variables, okay, but once you get to know how to solve this problem without any help that is being provided, okay, in terms of patterns or repeatability, okay, you can solve any problem that UPSC throws at you, okay. So All you need to find in cryptarithmetic problems is, okay, focus on the patterns we have seen and focus on the extreme digits. Always focus on the attacking point, which are edge digits, which is either the right side digit or the left side digit, and always look out for patterns, okay. One is range, next one is attacking edge digits, and next one is patterns, okay. Just keep these three in mind, you can solve it, okay. Now let us solve that CSAT question, okay. ABC into D results in, okay, ABC into D results in 37 DD, okay. I know cryptarithmetic way is not the efficient way to solve this problem, okay, but okay, we'll discuss this problem both from the point of cryptarithmetic and from the point of, or both from the point of cryptarithmetic and okay, any innovative way can, okay, can we solve this much more faster, okay. Okay, and do you find the pattern here? Okay, always attack at the edge digits. C into D is resulting in a D, okay. C into D is resulting in a D. Next, you see, D multiplied by B, okay, D multiplied by B, you will get sum and you will get a carry from the D into A is in the vicinity of 37, that means their product is in the vicinity of 37, the product is in the vicinity of 37, okay. These two are the patterns that I can find here, okay. Now let us focus on this. C into D is D, okay. C into D is equals to D. So what are the probabilities for C? C could be, okay, C could be a 6 or an odd digit, okay. C could be a 6 or an odd digit. How could be either 6 or an odd digit? We find it from the second pattern that we have discussed, A into B, okay. A into B is equals to B has, okay, either A as odd digit or 6. If A is an odd digit, okay, B is 5. If 6, it is some even digit 4, okay, some even digit 4. Okay. Now if I take it as C, if I take C as an odd digit, okay, C as an odd digit, then the value of D is 5, okay, the value of D is 5. So what will this become? It will become 3755 divided by 5. Now divide by 5, 5 sevens are 35, okay, 25, 5 5s are 25 and 5 1, okay. So ABC is 751, ABC is 751. You see, the value of D is 5 itself, okay, and the value of B is also 5, so that means D is not 5, okay, that means D is not 5, that means C is not odd digit, that means C is definitely 6, okay, C is definitely 6, okay. So the value of C is definitely 6, so D has to be an even digit, okay, D has to be an even digit, 4 6, okay, 8 or 0, okay, 4 6 8 or 0, okay. Can it be 0? 37 DD is 3700, D is what? 0, okay. Does this have any value? No, okay, so 0 is out of the question. Can it be 6? Okay, or 2. Can it be 6? Why? C into D is D. We are not talking of the property A into A is A, okay, so it can't be 6 2. Why? We have already a 6 in place of C, So D can't be 6. So 0 is gone. Okay, 6 is gone. So what are we left with? 2, 4 or 8. Okay, 2, 4 or 8. Now see. Okay, A into D. A is an unit digit. D is either 2, 4 or 8. Okay, A is either 2, 4 or 8. Okay, any single unit digit multiplied by 2. Any single unit digit multiplied by 2. Okay, what is the maximum? Maximum for A is 9. 9 2s are 18. 9 2s are 18. You see, A into D should be in the vicinity of 37. Okay, A into D, you got some result. Okay, and you will add some carry. So considering the carry, it should be in the range of 37. But A into D, the maximum you can get is 18. The maximum you can get is 18. So 2 is ruled out, right? Next, 4. 9 4s are 36. Okay, 9 4s are 36. It is in the vicinity of 36. Do you have any number of 8? Okay, in the vicinity of 37? Okay, 8 4s are 32. 8 5s are 40. Okay, 8 4s are 32 and 8 5s are 40. So nothing is in the vicinity of. Okay, if I multiply with it with 8, okay, it is, I have no number which is in the vicinity of 37. So this gives me an idea or probably a hint that my D is 4. Okay, my D is 4. So what does it become now? A, B, C into, okay, C is already 6. 6 into 4 is 37 4 4. Okay, so when you divide 37 4 4, divide by 4, what are you going to get? You are going to get 936. 936. In the exam they have asked for what is the value of A plus B plus C. It is 9 plus 6 plus 3, which is 18. Okay, this is from the view of cryptarithmetic. Okay, but this is not the efficient. Okay, this is not the most efficient way to solve this problem. What is the efficient way? Let us just see. Okay, I hope you have understood this. Every one of you has understood this. Okay, now okay, UPSC, okay, especially CSAT questions, whatever the questions okay, people find difficult. Okay, I have gone through at least all of the past years questions at least 4 or 5 times. Okay, for every question that the student thinks it is difficult, there is always an easier way to solve it. Okay, so what UPSC wants is, okay, it wants you to find the most efficient way. It wants the people to think. Okay, rather than doing it mechanically, UPSC wants people to think, okay, the efficient way to solve a problem. Okay, so A, B, C into D results in 37 DD. Okay, forget cryptarithmetic, forget whatever I have thought. Okay, we all know this, right? When I multiply 2 digits, okay, it results in another. Okay, now can I rearrange this? Can I rearrange this and write, okay, B by C is equals to A? I am doing nothing complex here. A multiplied by B results in a C. Can I write this simply as, okay, so C by B is equals to A, C by B is equals to A. Can I do this or not? Okay, just rearranging, nothing complex here. So what will this become? Okay, so if I, instead of viewing the problem in this way, if you are able to just think for a second, what is the most efficient way I can solve this problem, I can rearrange this as 37 DD divided by D is equals to A, B and C. Clear? Okay, is this clear? Now, okay, you see 37 DD should be divisible by D. 37 DD should be divisible by D. Okay, seeing this itself, I get a hint. Okay, what is what is the divisibility rule for 4? What is the divisibility rule for 4?
मेंस टेस्ट सीरीज के स्टूडेंट
हो जाएगा 5 मिनट
हाँ वो वाइंड अप कर देते थे 5-6 मिनट 12:30 पे सर का वो
ठीक है हाँ 5 मिनट okay 37dd divided by b okay is abc. I get that the divisibility rule okay it is the first thing that everybody teaches in a class, in a number systems class, okay, first few lectures only you will see, okay. Anything I know that this is okay 37dd is a multiple of d, okay, that means 37dd is should be divisible by d. So seeing this pattern itself, you see, if the last 2 digits are divisible by d, then the whole number must be divisible by d, okay, then the whole number must be divisible by d. Don't you think it is similar to divisibility rule of 4? Okay, now substitute, okay, just for the sake, okay, why? Because anything with dd, okay, you can dd by d, okay, 66 by 6 is 11, anything is multiple of this case, but okay, but substituting this you cannot guarantee that 3766 by 6 is divisible by 6, okay, you cannot guarantee that, except in the case of 4. That is what divisibility rule of 4 is, which is okay, if the last 2 digits are divisible by, okay, if the last 2 digits are divisible by the number, then the whole digit is divisible by number. So once you do this, okay, once you just find out, okay, 3744 divided by 4 will give you 936. So a plus b plus c is 936, okay. You could have solved the cryptarithmatic way, or by using a little logic itself, okay, by using the little logic itself you could have done this, okay. I hope from now on any cryptarithmatic problem, just follow the basics that we have taught in the class, okay. Only 3 things are important. First important thing is attacking points, okay, attacking points which are always at the edges, focus on the edge points. Next, focus on the range, okay, focus on the range. And the third one is focus on the patterns, a into a pattern, or a into b is equals to a, or is the unit digit stopping at 1, okay. I hope this gives you one shot of any cryptarithmatic problem. Just follow these 3 principles, you will be able to definitely solve those, okay. I hope this session has been quite revealing and informative to you, okay. In the next open session, okay, I see that many problems, okay, rather than, because in the course of a normal CSAT course, what we see is we deal with regular topics, okay, but in this series I want to take up some new exotic topics, those which students feel difficult and which UPSC has been focusing on, okay. So on this session we are doing cryptarithmatic. In the next session we will do, okay, problems on, okay, a niche topic on niche application of percentages is election based problems, okay. In the next open session we will deal with a one shot way to deal all election based problems, okay. I hope you have enjoyed this as much as I enjoyed teaching you. We'll take a leave here, and the next session is going to be on elections. I hope many of you come and participate in it. Thank you.